Thanks for joining today's class. We want to talk about deployment and management of containers with Azure Kubernetes. Deployment and management of containers with Azure Kubernetes. First, Azure Kubernetes Service. There's an architecture that I want to explain here, which are the basic components for Azure Kubernetes Service. You can see them in this architecture. So let's start from the Azure Kubernetes Service. AKS is a managed Kubernetes cluster hosted in the Azure cloud. Azure manages the Kubernetes API service, and you only need to manage the agent nodes. You can see that there is a virtual network in this architecture. By default, AKS creates a virtual network into which agent nodes are connected. You can create the virtual network for more advanced scenarios, which lets you control things like subnet configuration, on-premises connectivity, and IP addressing. You can also see ingress. An ingress server exposes HTTPS routes to services inside the cluster. You can also see Azure Load Balancer. Once the AKS cluster is created, the cluster is ready to use the load balancer. Then once the Nginx service is deployed, the load balancer is configured with a new public IP that will front your ingress controller. This way, the load balancer routes internet traffic to the ingress. You can also see the SQL database, the Cosmo DB, which we call external data stores. Microservices are typically stateless and write states to external data stores such as Azure SQL database and Azure Cosmo DB. Azure Active Directory is also there. You can see AKS uses Microsoft Entra ID identity to create and manage other resources such as Azure Load Balancer. Azure AD is also recommended for user authentication in client applications. You can also see the ACR, which is Azure Container Registry. AKS uses Container Registry to store private Docker images, which are deployed to the clusters. AKS can authenticate with Container Registry using its Azure AD identity. AKS doesn't require Azure Container Registry. You can use other container registries such as Docker Hub. Azure Monitor, which is the last part below. Azure Monitor collects and stores metrics and logs, application telemetry, and platform metrics for the Azure services. Use this data to monitor the application, set up alerts, dashboards, and perform root cause analysis of failures. Azure Monitor integrates with AKS to collect metrics from controllers, nodes, and containers. Next is Azure Kubernetes Cluster Architecture. As you can see in this drawing, Kubernetes is a cluster of a virtual or on-premises machine. This machine is called nodes. Share compute, network, and storage resources. Each cluster has one master node connected to one or more worker nodes. The worker nodes are responsible for running groups of containerized applications and workloads known as pods, and the master node manages which pods run on which worker nodes. A cluster, Kubernetes cluster, which are divided into two components. A cluster is a set of computers that you configure to work together and view as a single system. A Kubernetes cluster contains at least one main plane or one more nodes. Both the control panels and the node instances can be physical devices, virtual machines, or instances in the cloud. The default host OS in Kubernetes is Linux, with default support for Linux-based workload. You can also see this. Developers and operators interact with the cluster primarily through the master node by using kubectl. a command line interface that installs on their local OS. Commands issued to the cluster through kubectl are sent to the kube API server, the Kubernetes API that resides on the master node. The kube API server then communicates requests to the kube controller manager in the master node, which is in turn responsible for handling worker node operations. Commands from the master nodes are sent to the kubelets on the worker nodes. In a Kubernetes deployment, the desired state you describe becomes the current state in the etcd, but the previous state isn't lost. Kubernetes support rollbacks, rolling updates and pausing rollouts. Additionally, deployment use replica sets in the background to ensure that the specified number of identically configured pods are running. If one or more pods happen to fail, the replica set replaces them. In this way, Kubernetes is said to be self-healing.